Water is the foundation, the source, and the mechanisms that govern life, but also govern the whole biosystem and the climate of the blue planet.
Our groundwater is a treasure. It's a miracle. Somehow it's a miracle.
I spend more than $1 million every year on electricity to pump water.
We have a larger impact on the planet than ever before. The climate, the water, the land, biodiversity, the oceans.
The cycle of water and being able to understand that is one of the most critical questions that we have to deal with today in a changing climate.
It is dangerous hydrological climate extremes that are going to be threatening a whole lot of different ecological and human values.
Eventually we cook ourselves as this frog in warm water. It cooks before it realizes that the water is so hot that it is going to die.
So we really have it in our hands now to understand so that we can sustain the health of the human population.
Water is the foundation of all life as we know it, but it's the most wasted natural resource, reflecting man's intense and short time on Earth. Water is life. We measure it in drinking water, but it's much more than that. Water must be present in all of the planet's systems for it to be in balance.
You can think of water as Earth's blood supply. It flows through the landscape and supplies nutrients to nature and plants. Water is also the source of human life and society.
If we manage the water as we do now, where we use it, pollute it, and then try to dispose of it with very serious consequences, that system is not sustainable. Under that current system of water use, we are running out of water.
We are losing more and more useful water. The association between the imbalance of the water cycle and climate-related problems is bigger than what most people are aware of. We are also not taking care of our most important substance. We just regard it as any liquid. Still, water is the very foundation of life itself.
Water was, to a large degree, formed as the Earth took shape. It's a chemical compound of 2 hydrogen atoms and 1 oxygen atom. It's a simple compound, but with very distinct qualities.
Water is one of the universe's most unique materials. It has completely unexpected, unique properties.
We have it as vapor. We have it as liquid water running down rivers and in lakes and in the oceans. We have it as snow and ice in its coldest phase.
"97% of the planet's water is saline and found in the oceans. The remaining 3% is fresh water, of which more than half is contained in glaciers. Only about 1% is available to us. Nevertheless, we act as if water is an endless resource.
Water is something that we all take for granted until it's not there. We just take it for granted Nowhere you go, we're going to turn the tap in a hotel room or another city that there's going to be water there. I saw a study that the majority of the people in the state don't know where their water comes from. They just know the water bill when it comes.
We don't understand the value of water, nor that the hydrosphere is crucial for the ecosystems that we depend upon, and in the magic in that everything is created in the meeting between sun and water.
Solar energy cleanses seawater and produces fresh water. Nature is constantly cleansing water in the water cycle. Rainwater is clean, but unfortunately chemicals can be dissolved into it in the atmosphere.
The amount of fresh water on the planet depends effectively on evaporation and transpiration. Because, you see, as water evaporates, it leaves behind all the salts and the pollutants that may be in the oceans or where it's from, and it just goes up as water vapor, pure water vapor. And so it regenerates fresh water.
At a certain level and temperature, water vapor condenses, mostly into ice particles or snowflakes that form clouds. When the clouds get heavy enough, to put it simply, you get precipitation.
Precipitation. Rain and snow that falls in large volumes to hardly at all. For water molecules to form drops, it's been discovered that aerosols are needed. Small ice and salt crystals, which are the starting point for condensation.
One million of these cloud microdroplets need to be coalesced into each raindrop for it to be heavy enough and large enough to fall out of the air under gravity back to the land. And so this nucleation of these water droplets is a key balancing process in nature in driving rainfall.
But there are other aerosols that are important for creating raindrops. Bacteria. Through the evaporation of trees, specific bacteria end up in the atmosphere where they bind water vapor and create drops. The bacteria return to Earth with the rain that they themselves created.
We have precipitation that comes down onto the surface of Earth. That either goes into the oceans or it goes onto the land. If it goes onto the land, then some of it percolates down into the ground, some of it evaporates back into the atmosphere, some of it goes into the plants, some of it runs down the hill right away. If it falls as snow, then the beauty of that is that it stays as a mountain reservoir of water, and it doesn't move out of its system very quickly. So there's just this constant exchange of water moving across the surface, under the surface, into the atmosphere, and then back down onto the surface.
When the rain falls down and it becomes groundwater and it goes slowly to deeper, then it takes up minerals. Here in Brabant, we have groundwater at about 80 meters deep and about 200 meters deep. It's coming from Belgium, and it travels with a speed of about 20 meters per year, so it's very slowly. And it took about 10,000 years to come from Belgium to here. We use it for drinking water and to irrigate our crops.
It's also known as fossil water. Depending on the bedrock, age may vary. But most groundwater reservoirs are ancient and were created long before humanity appeared on Earth. It's formed by rainfall that dissolves minerals and nutrients. It's the best and purest of all water, and the most important water resource for us and the ecosystems.
If you pump groundwater, and in every year you're using that groundwater without it being replenished, then the groundwater is going to decrease. Well, how far can it go?
You know how much water we pump here? 2 billion with a B gallons a year. I spend more than $1 million every year on electricity to pump water.
It's the land of the big acreages. Fromm farmland grows animal feed, such as corn and grain, on 14,000 hectares. These cultivations are possible thanks to one of the world's largest systems of fossil groundwater being available. Ogallala Aquifer supplies 8 states and about 2.5 million inhabitants with water, but the levels are dropping.
Unfortunately, we've pumped in this area at least 30% of the aquifer, I'll say dry, or we've lowered it. And as we do that, the well is more pressed to give up the water. And there's a lot of wells that only pump half of what they did when they were first developed.
There might be enough water for 50 to 70 years. Then it'll be gone. Groundwater is being overused all over the world.
Large-scale operation and monoculture cost water. It's not only the farms in Kansas that consume. About 70% of the planet's fresh water goes to cultivation and food production. Do the large-scale monocultures drain the groundwater systems to dangerously low levels?
Will the Ogallala Aquifer ever be drained? It is being drained right now. I've heard people use the word mined because it's something that's taken out of the ground and not put back, as if we were mining gold or pumping oil. It's a mining operation.
Thousands of years were required to create these groundwater supplies. And so pumping those out of there, in order to get back to the same aquifer level that we had before we started pumping them, it's going to take a long time.
And so this creates enormous problems in the next couple of decades because the agriculture that depends on that water is designed to collapse.
We extract more than what is replenished. We're draining the world's most important water resources. But there is another very important water existing in environments that we hardly think of. The soil water. A hidden resource found in the soil, which is essential for life in the biosphere.
The Earth's soil, which cover, that 29% or 13 billion hectares of land surface, are really a big sponge. And depending on the quality of that sponge, they can hold up to 50% of their volume in water.
Significant amount of water is actually stored within the soil sponge and as a groundwater. And as a matter of fact, it is more than the water that we just see in the form of rivers and lakes.
In order for soil and cultivated land to function and supply water, it must be healthy and alive. Microorganisms and organic matter preserve water. In a time when rainfall is unpredictable, this is extremely important.
The critical thing is that what happens to every raindrop that falls on this Earth's surface? Does it infiltrate and get retained in a form and location where it's available for plant growth? Or does it run off, erode soils and biosystems, and then get lost into the ocean? And the difference whether it infiltrates or runs off depends on the Earth's soil carbon sponge. Whether that sponge can have the porosity and the permeability to absorb that water and then feed it into the deeper soil horizons, which are our in-soil reservoirs, because it's that water that governs life in the biosystem.
The industrial form of farming does deform the ability of soil to soak water. It just loses the humus, and you have very compact soil. On top of that, which is dry, let's say you have a heavy rain or any form of precipitation, it just slips on the surface because the soil becomes hydrophobic. So the soil sponge is leaving us, the groundwater recharge is leaving us because of that. So we're just flushing the vital component of life away from ourselves.
It comes down to impoverished soil that has lost its capacity to infiltrate and its ability to hold water. At the same time, we drain and divert the water from its natural cycle. We urbanize the planet through industrial development, and the soil horizon that was an important water reservoir is being sealed under concrete and infrastructure.
Cities are growing, and we're asphalting the planet. We tarmac the farmland. We isolate farmland from the water cycle. Drainage diverts surface water into rivers and lakes, and it's often quite polluted. Water from heavy rainfall has nowhere to go. It runs straight into the sea. It isn't put to use. It doesn't replenish the groundwater. It's not a resource.
And if we drain the water, we decrease the wetland, we decrease the biodiversity, we decrease the water infiltration, so we decrease the water cycle.
We consume groundwater and create hydrophobic soils. We isolate the soil under hardened lands, and the precipitation is diverted. This means less water on the continents and declining groundwater systems. And the consequences of this are extensive.
Dehydration is the long-term process of less and less water reaching the groundwater. That makes that, for instance, trees and other plants can't reach the groundwater anymore.
And the impact to it is actually quite horrific, because eventually we cook ourselves as this frog in warm water. You know, it cooks before it realizes that the water is so hot that it is going to die. With every drop that we flush away, less water is coming in. And this is how the desertification comes in slowly but surely.
Different regions are experiencing already significant aridification. losing 20 to 30% of their rainfall and risk turning more and more into deserts.
When nature withers from thirst, it gets warmer. More solar energy, and neither water nor vegetation can help the cooling of the soil. Our consumption and use of water resources have a direct impact on global temperature and our climate.
It is water that, in a sense, governs 95% of the heat dynamics of the blue planet. And for the last 4 billion years, it is water that has actually regulated the climate. It's the different water processes that govern these dynamics.
Our research shows that it's not just a matter of climate change. Things we do at ground level have an impact. Intensified farming to increase the yield per square meter, or if the acreage increases, or we use more water, we increase transpiration.
Up to now, we've been so focused exclusively almost on the CO2 concentration in the atmosphere that has obviously gone up abnormally. You know, we have assumed that the CO2 rise, because it is a greenhouse gas, has caused the planet to heat up. And certainly that is a key contributing factor. But a far, far bigger factor has been the changes we've been making to the Earth's hydrology.
Not only do we release previously reserved water that increases the amount of water vapor in the atmosphere, but we also contribute to global warming by large-scale monocultivation and increasing urbanization. We create islands of heat that repulse clouds and rainfall.
If we have a green vegetated landscape with transpiration cooling, the soils under that landscape rarely get above 20 degrees centigrade, even in tropical regions. Conversely, where we have bare, exposed soil, subject to the incident solar radiation, especially soil that hasn't got water, that soil or asphalt or concrete or that surface can often heat up to 60 degrees centigrade or above, which means that profoundly more infrared heat is re-radiated from hot surfaces compared to cold surfaces.
The monocultures and industrial farming do bring along this phenomena of heat island, because from one day to another, a large area is harvested, and from one day to another, you just switched on, in a snap of a finger, a nuclear power plant that is radiating upwards. So this is how the agriculture and the industrial form of agriculture deforms the weather.
A warm atmosphere can contain more water than a cold one. We can safely assume that hurricanes and ensuing severe rainfall will become more frequent. And they will intensify.
We water the atmosphere with fresh water. And with rising temperatures, the hydrological cycle is affected. It's difficult to observe, but imbalance contributes to weather processes that affect every part of the planet.
It is dangerous hydrological climate extremes that are going to be impacting, intensifying, and really threatening a whole lot of different ecological and human values. These are hurricanes, these are storms, floods, aridification, droughts, wildfires. And it's these hydrological extremes that kill human beings.
The climatic effect on the water leads to disastrous floods and droughts. The long-term effects can change the conditions for a large number of societies on Earth. Could these extremes be the norm in 50 years? How are we going to handle them?
Extreme will become the norm. Don't we already see it today? That environments change for the worse for all living beings. What will our existence look like in the future? It seems uncertain with a changing worldview.
We can do okay when we get droughts and we get wet periods and it's minor. But if it comes 4, 5, 6 years of intense drought, or as in the Colorado River Basin now, we're in 18 years of drought. We have 40 million people in the state of California that are very strongly dependent on that water resource. Where are they going to go if it goes too dry? People don't survive those, they have to move. Civilizations don't survive those.
Lack of fresh water is a reality in many parts of the world. But that's far away, not here. Water is also consumed through direct consumption and as a commodity in our trading systems. It's a virtual, invisible water that hides primarily in products linked to cultivation and agriculture.
A lot of goods are imported from regions where there's a shortage of water. A lot of water flows from arid areas to areas where water resources are already plentiful.
We tend to think of water as a local resource, but trading goods means we have an impact on each other. There's water in everything.
För vatten finns i allting.
Everything contains water, from textiles to cut flowers. Our lifestyles are costly, and we exhaust water-stressed nations' access and right to safe, clean water. It's not only about products. Half of the food we consume is imported.
Kring 30 to 40% of all foodstuffs are never consumed. They're ruined by poor storage or poor handling, or just thrown away. The equivalent to the U.S. production of foodstuffs is just thrown away. And that means we're also wasting water.
We consume large volumes of water through overproduction and discarded food. Things that don't just waste resources, but also generate pollution.
Our water reflects our behavior because sooner or later everything we do or use or have ends up in the water.
The chemical footprint that we're finding in rivers and lakes is definitely a reflection of how human society interacts with waters. When we're taking samples near a city, it's more dominated by detergents. In an agricultural area, it's more dominated by pesticides. If you take it near a mining area, you have a lot of heavy metals in there. So we can clearly see that human activities are driving the chemical footprint in a river or a lake.
Of the agricultural use of water here in our state of Kansas, the majority would be for watering crops. And one of the concerns as water filters through the soil and makes it all the way down to where the aquifer is water quality. And the one big concern we have is leaching of nitrogen fertilizer.
In this county we have a lot of livestock, so we have a problem with far too much manure, and we see that in our groundwater and also in the water in the ditches and in the canals. So I think nitrate in the groundwater is also a problem for biodiversity in the soil.
The nitrogen leaches down into the aquifer, which contaminates it for drinking, and it isn't just irrigation water that can do that. One of the big sources is runoff from feedlots. Kansas is the largest meat packing state in the United States, and there are areas around feedlots where the drinking water is too contaminated to drink.
It's not just the fertilizers from the meat industry that affect water resources negatively and pollute groundwater. The water that naturally gives us minerals and nutrition also gives us completely different substances.
Water is an excellent solvent. It absorbs pollution so that it becomes part of the cycle. There are all sorts of pollutants in different parts of the water system. Cleaning it up is energy and cost intensive. The question is, how much of it can we cleanse out? The pollutants are a big problem. There are many unrecorded issues. We don't carry out tests everywhere.
We dilute the chemicals in the belief that the consequences will be smaller. But despite our efforts to minimize risks, the effects of our usage of chemicals are extensive and already noticeable.
The drugs that are in the surface water are painkillers, blood pressure medicines, diabetes, anti-epilepticals, all sorts of medicines we use daily, antibiotics. And, well, they have all different effects on the ecosystems in the water.
Our naive relationship to chemicals and chemically manufactured products is unsustainable. This makes large volumes of the available water on Earth useless. And in addition, we have plastic.
There are plastics in tap water. There are plastics even more often in bottled water. We're drinking plastics. Each day, per square meter indoors, more than 300 plastic microparticles collect. Leave a glass of water on the table, and you'll be exposed to them. They're in the air, water, and food. The impact on humans has yet to be studied. We're starting to understand the impact on animals and organisms, but we don't yet know the full effects.
Men vi har ingen bra samlad svar på effekten.
Plastic is everywhere. And in places where people often meet, artificial turf, small plastic fragments, and granules make their way down the sewage systems. There's also the possibility that microparticles attract and collect chemicals. What happened? The water cycle is everywhere. Cleaning, filtering, drinking water, rainfall, climate balance. But it has been downgraded to a consumable and a transport system for pollution. The planet's bloodstream is draining. And surely this reflects on us as humans and our short and intense time on Earth.
Over the last 200 years, that's the period that humans have really come to have an enormous influence on the Earth system. And industrialization itself is not all bad. It's just how we capture what we're doing and understand how we're influencing ourselves, influencing our ecosystem, influencing our water supply.
Biodiversity is like a pyramid. At the top of the pyramid, this is a place for human being. And if biodiversity disappears, human beings disappear too. So it's very important to protect the biodiversity. And also there is a big connection with water. Clearly all this area play a role for the good water capture, but also for the good water infiltration, like the peat moss. And this area is also important to reduce the global warming. It's a wet and peaty area, and this kind of area it's able to catch or to capture 10 times more CO2, greenhouse gas, than another soil. It's very important to preserve this place to catch and to reduce the global warming.
We have to take carbon out of the air that was basically put there from our degradation of our landscape, and put that back into our soils to rebuild the sponge so we can rebuild the hydrology. 2 to 3% carbon added into the soil can create these structural regeneration effects, add voids, surfaces into that soil matrix, and really rebuild healthy soils.
Through photosynthesis, carbon can be bound in the soil, letting nature transform carbon dioxide into a rich soil, with microorganisms that make the soil healthy and water-retaining. This way, the climate, the water balance, and our arable land will be positively affected.
In the spring, when the photosynthesis turns on, you will see significant drop in terms of the amount of carbon dioxide in the atmosphere, which goes down as the photosynthesis progresses through the summer. And then when we hit the fall and everything is harvested, again you will see a significant increase in terms of the concentration of the carbon dioxide. So this shows the magnitude of impact that the photosynthesis has on the amount of carbon dioxide in the atmosphere.
Soils are also fundamental because it's the only point of agency, the only point of influence we humans have on the Earth's climate, hydrology, and our future. You see, we can't change the oceans, we can't really change the ice caps, we can't really change the atmosphere, we can to some extent, but the real point of agency is the sponge.
There is clearly an overconsumption of the water resources on the planet, a consumption that affects the climate, the ecosystems, and everyone on Earth. We have to end the idea that fresh water is infinite, and we have to understand the value of the hydrological cycle, as well as the solutions that nature has already developed for the climate.
We are not using the systems that nature provides us, the lesson that nature provides us, and we think we are above nature. And we have lived the last century with delusions that we can fix things technologically. But I think the reality is coming that there are limits, there is an imperative for regeneration, and hopefully we will have the wisdom to now say, hey, let us work with nature. Let us get our boot off her throat and let her breathe and let her help her to actually regenerate these biosystems.
We should be more aware of the fact that our groundwater is a treasure and use it with respect as you treat a treasure. It's a miracle. Somehow it's a miracle. But we are so used to it that we can't see the miracle in it anymore.
What society has to do now is monitor how we use our water resources so that we avoid overuse and too much pollution, which would ruin the basis of our existence.
So we really have it in our hands now to understand how these water supplies are changing, these water fluxes, as well as the interaction with the climate are changing, so that we can sustain the standard of living and the health of the human population.
We are one. Us, the water, and nature. We need to rethink, to stop polluting and draining, and instead retain the water on the continents. Be conscious of carbon storage and think of cultivation methods that replenish the water in the soil, in the ecosystems, and in the groundwater. We must think of photosynthesis and nature's own climate control. But we must also understand that balance in the water cycle is a fundamental condition for our future.
Clearly, we have messed up the show. We have degraded these lands, the sponges, the in-soil reservoirs, the hydrology, the cooling of the planet. Nature will always be here, however, and nature can and will restore these biosystems. The only question is, will we help her do that, or let her do it by herself after we are gone?